like the analysis of continuous beam, which is having a sinking of support. This we were doing in the previous class, and in the previous class we have completed till the calculation of the moments. This one we completed. So now what we are supposed to do, we will use this table and we will calculate the different matrices. Okay, so let's start. So what I'll do, so this will be so this is actually the step 3. This is the step 3. So we will use these 3 and we will put this one in this equation. In this equation, we will put all those values and we will find out the different matrices. Okay. So all of you might be knowing this this formula over here, which I told earlier. So capital D minus DL equals to F into P. So this, so the size of this F, that is the flexibility matrix, is, I told you earlier, it is 2 cross 2, it is 2 cross 1, this is again 2 cross 1, and this is again 2 cross 1. Okay, since the degree of static indeterminacy is 2, so we will be having the values like this. Okay, or the dimensions like this. Okay, so now the first one is we will determine this DL matrix first, that is the displacement matrix due to the externally applied loads. Okay, so DL, so all of you please keep your calculators ready because we now need to do the integration. Okay, so this DL will be D1L, D2L, because there are the degree of static indeterminacy is 2. Okay, so this D1L will be given by the equation integration 0 to L M into M1 divided by EI into D. Okay, so this is the first one, and the second one is again integration 0 to L M into small m m2, small m2, this one, small m2 into dx divided by EI. Okay, so this is the table which we have done. Okay, and for every segment we have to determine this value. Okay, so for every segment we have to determine this value.
Sir, excuse me, sir. Screen,
Yes,
screen is not visible.
screen is not visible. Just wait. You please check your net pack because my net pack, it is there. I have data.
Yeah, your net is good, sir. Please check others' internet. For me, it's visible.
Okay.
హర్ష నెట్ రావట్లేదు హర్ష.
So
Sorry, in my case also
net
the screen is not
coming
visible, sir.
guys, then I'm recording this one and I'll upload it from YouTube. You can download the same video if you don't have net pack now, not now. Okay, so now what we will do, we will multiply this m1 for AB. Okay, so here what we can do, we can say it as summation. Okay, so summation for this one, for if you see for the segment CE, for the segment CE, this one, this is C, and this is C, and this is E. So for the segment C, M is 0, M1 is 0. So no need to do that one because the integration will be 0 again. This will be 0. Okay. Now again minus 40 into x into 0. Okay. So this is again coming as 0. So we are left with this one and this one. Okay. So I will directly write. Okay. Or what I will do, I will write individually d1l equals to integration 0 to L, 0 to L is limit is 0 to 2. So 0 to 2 into minus 40 into x plus 2 into x into x divided by what is EI? EI is 2EI. Okay, so here it was EI, but in case of this one it is 2EI. So I will write it as 2EI plus integration 0 to 2, because here also integration it is 0 to 2. Again it is minus 80 x, then minus 40 into x plus 4, then this one into x plus 2 into x plus 2 into dx. I forgot dx here, divided by again this is 2EI. So all of you please integrate and find out the value. Please do the integration. So if you do the integration, the value of d1l, I am writing it here because again you guys will take a lot of time to integrate, and by the time you integrate our class will be over. Okay, so similarly so this implies this is d1l, and similarly I am writing d2l also. So d2l, so you can see here, so d2l equals to more, so d2l equals to again this summation 0 to L m into m2. Okay, so m into m2 means this one. Okay, this is 1 into x, so m into m2 is this is 0, so this will be there. Okay, so integration again L is varying 0 to 2 for every member. L is the length is varying from 0 to 2. Okay, so I will directly write integration 0 to 2, this is minus 40 into x plus 2 divided by, here the value of EI is 1. You can see here the value of EI is 1. Okay, so divided by EI, then plus integration 0 to 2, it is minus 40 into x plus 2 into x plus 4. See this, this is minus 40 into x plus 2 into x plus 4 divided by, it is 2ei, this you can see, it is 2ei, okay, so 2ei, then again plus the same one, integration 0 to 2, it is minus 80 minus 80x minus 40 into x plus 4 into x plus 6. This is 80x, okay, this is 2ei into dx, and I forgot dx also here, even here also I forgot dx. Okay, so if you integrate this value, you will get d2l, this implies d2l, it is equal to minus 20880 divided by ei. Okay, so now, so here I can write, this implies dol equals to d1l d2l, that is equal to minus 1013.33 divided by ei and minus 20880 by ei. Okay, so we have done this one. Okay, now this one. So if you see, so this d equals to this d. This d equals to, this displacement is the displacement or the sinking of supports. Okay, so this we can call it as delta b and delta c. So so this is the sinking value. Okay, so sinking value, how much is the sinking in the, it is given in the question. So the support c and d are sinking by 10 mm. Okay, so we are taking upward direction, we are taking upward direction as positive. So if the support is sinking, means it is going down. So since it is going down, I am considering this negative sign here. Okay, so minus 10 mm and minus 5 mm. But all our expressions are in the form of kilonewton meter or kilonewton per meter, like that. Okay, it doesn't kilonewton and meter. Okay, so this again we need to convert it into mm, meters. So this will be minus 10 mm equals to minus 0.01 meters, and this is minus 0.005 meters. Okay, now, so we have found out the wait, I will use this thing. So we have found out d, we have found out dl. Okay, now we need to find out the flexibility matrix. Okay, so this flexibility matrix is due to the unit loads over here. Unit loads, whatever we have applied, unit load we have applied here for case 1, here we have applied for case 2. So that we will write. Okay. So, and I will use these formulas. Okay, I will use this formula. These values, sorry, not these entirely, only these two values I need. Okay, so you just pay attention to your notes in which you are writing so that you can understand that one. Okay, so the flexibility matrix, that is F equals to flexibility matrix F equals to F11, F12, F21, F22. Okay, so this F11, F11 equals to integration 0 to L M1 into M1 into dx by EI. Okay, and again this is summation. Okay, so now if you see here, so this M1 and M1 means M1 square, that is this one. So for each, so for each section, this one M1 square is 0 here. Again here is M1 square is 0. Okay, so here M1 square means x square. Here M1 square means x plus 2 whole square. Okay, again the integration is from 0 to 2. The integration is from 0 to 2. Here also integration from 0 to 2, and EI is 2EI and 2EI. Okay, so those we need to write. Okay, so this F11 equals to F11 equals to, so the first one is 0 plus 0 plus integration 0 to 2, and the first one is, sorry, sorry, this is this is, no, this is correct. So it is x square into dx by 2ei plus integration 0 to 2 x plus 2 whole square into dx by 2a. Okay, so again if you solve this one, you will find F11 equals to 10.667 by EI, and similarly this F12 will be equals to F21, and this will be summation 0 to L M1 into M2 divided by EI into dx. Okay, so if you put all the values and if you do the summation, it will be 0 plus 0 plus integration 0 to 2, it is x into x plus 4 whole divided by 2ei plus integration 0 to 2 x plus 2 into x plus 6 whole divided by 2ei into dx. So this on solution, it will be 26.67 by EI. This implies F21 equals to F12 also. Okay, next one. So just like F11, we will have F22 equals to integration 0 to L summation. This is M2 into M2 into dx divided, here I am forgetting dx, divided by EI. So this will be integration 0 to 2 x square dx by EI plus integration 0 to 2 x plus 2 whole square into dx by EI plus integration 0 to 2 x plus 4 whole square dx divided by 2ei plus integration 0 to 2 into x plus 6 whole square into dx divided by 2ei. So if you solve this one, you will get the value, and then we symbolize f22 equals to 96.0 by ei. So finally f equals to f11, f12, f21, f22. This if we put, it will be 1 by ei into 10.667. This is 26.67. This is again 26.67, and this is 96.0. Okay, so we have found we have calculated d, dl, f. Now what is this p? So this p is the load vector, and this load vector is the redundants which we have taken. So what are the redundants we have taken? Who can tell what are the redundants we have taken? You can see here, I have written here. The redundants are, sorry, not RB, RB and RA. This is redundants are RB and RC. It is RB and RC. Okay, so these two are the redundants. So simply what we will do, we will put in the equation. So if we put everything in the equation, we have so we already know that d minus dl equals to f into p. So d minus d is, this is minus 0.01 minus 0.005 into minus, this is minus 1013.33 by ei, and this is minus 20880 divided by ei equals to, f is this one, so 1 by ei into, or let us put this 1 by ei inside. Okay, so this will be 10.667 divided by ei. This is 26.67 divided by ei. This is 26.67 divided by ei, and this is 96.0 into, or into, this is RB into RC. Okay, so if you solve this one, okay, before solving, we EI, it is, what is the value of EI? It is given in the question. What is the value of EI? What is the value of EI? Who can tell? What is the value of EI? Prem Kishore, what is the value of EI given in the question?
Sir, 180 into 10 to the power minus 4 Newton per mm square.
Newton per mm square. Okay, so we need to, so it is given as 180 into 10 to the power minus
4.
4, 4 or 11 or 4. Which one? How much it
4,
is?
sir.
Minus 4 Newton per.
Per mm square.
Okay, so if you convert it into kilonewton per meter square, what will be the value? What will be the value? So this will be 18,000 kilonewton per meter square. Okay, so this value you need to put here, here. This is also by EI, my mistake. Here, here, and you need to put the value. So if you put the value, again this will be simplified as, this implies minus 0.01, sorry, and minus 0.005 minus this I'm directly writing, minus 1013.33 divided by 18,000, and this is minus 20880 divided by 18,000 equals to 10.667 divided by 18,000. This is 26.67 divided by 18,000. This is 26.67 divided by 18,000. This is 96 by 18,000 into RB RC. So if we find out, so if you inverse this one, you have to inverse this one. So this we can write it as RB RC equals to 10.667 divided by 18,000. This is 26.67 divided by 18,000. Again 26.67 divided by 18,000. This is 96 by 18,000. Inverse of this one into, if you will do this one, it will be 0.0463 and 0.155. So finally the RB value, so RB RC equals to 17.893 kilonewton, and it is 24.092 kilonewton. Okay, so the redundant forces are like this. So in your actual structure, this was your actual structure. So this is A, this is B, this is C, and here we have 40 kilonewton, here we have 80 kilonewton, and this distance is 2 meters. This is again 2 meters. This one is already given again as 2 meters. This is already given as 2 meters. Okay, so this one, so RB equals to 17.893 and RC equals to 24.092. Okay, so since these two are positive, it means the reaction, the actual reaction will be in this direction or towards the up, in the upward direction, Okay, so now, so we have found out the RB and RC. Okay, so the next step is to find out the other reactions. Okay, so the fourth step will be step 4. That is the reactions. So let us take the first span as span BC. Okay, this is span, this is B, this is C. So here it is, let's say the reaction is RBC, and let us say the reaction here is RC, it is coming as 24.092. Now you may say, sir, RB we have already determined. Why we need to determine RBC? Because here whatever reaction will be there, this will be the summation of RBA and RBC. Okay, so that's why I am giving it as, for this member here I am giving the reaction name as RBC. Okay, so we already know that RBC plus, so here we have 140 kilonewton load. Okay, let us say this point is called as P. For example, I am saying this point is P. Okay, so RBC, so if we make the summation Fy equals to 0, then RBC plus RC minus 40 equals to 0. This implies RBC equals to 40 minus RC. This implies RBC equals to 40 minus 24.092. So it is, so this implies RBC equals to 15.908 kilonewton. Okay, so this RBC is 15.908. So now what are the next things we need to find out? We already know that here the moment will be, what will be the value of moment here? Moment will be, since this is a hinged end, or you may call it as simply supported end. So this, so moment here will be 0. Here moment will be there. So let us say I am assuming it is in this direction, and I am assuming the moment in this direction. Similarly, let us say I am assuming it is this one. Okay, so let us say this is, so this one, it is 0 moment. Okay, so I am just writing 0 value, and here let's say I am assuming in this direction. So MBC equals to, I have to find it out. Okay, so how I will find that one? So let us take moment across point B equals to 0. Okay, so summation MB equals to 0. So if I do that, we will have, you see, this distance, it is 2 meters, and this is 2 meters. So just like the moment, so whenever we are finding out in slope deflection or moment distribution, what equations and all, okay, or slope deflection equation. So just like that, we need to find it out here. That is 40 into 2 plus MBC minus RC into 4 equals to 0. So this implies 80 plus MBC minus RC is 24.092 into 4 equals to 0. So this implies MBC will be how much? MBC equals to 16.37 kilonewton meter. Okay, so MBC means this one. It is coming as 16.37. So this is 16.37. Now, if this is in this direction, then this movement will be definitely in this direction, but will not be assuming that one. Let us find how much is that MBA. Okay, so in order to find out MBA, what I will do, I'll take this again. This is A, this is B, and this I am assuming MBA. Okay, and this I am assuming it as MAB. Okay, and here this is RBA, and here we have RA. Okay, and here I am having 80 kilonewton, and that too, this distance from here to here it is 2 meters, and from here to here it is again 2 meters. Okay, so can I write RB equals to RBA plus RBC? Okay, because this we already know that I told here that this RB value, this value is this RB equals to RBA plus RBC. That is what I have written here. So RBA equals to, RB equals to RBA plus RBC. So if you put the value, this implies 17.893 equals to RBA plus RBC is 15.908. So this implies RBA equals to, it is coming as 78.015 kilonewton. Okay, so this is 78.015 kilonewton. Okay, again we can sum Fy, summation Fy equals to 0. This implies RA plus RBA minus 80 equals to 0. So this implies RA equals to 80 minus RBA. This implies RA equals to 80 minus 78.015. This implies RA equals to sorry. This is RBA equals to, if you put this value, nobody is saying this one. Okay, sir, you have written wrong here. So this is 78.015 and this is kilonewton. Okay, next, now at this joint, or if you see this one, at this joint, okay, at this joint, the moment at this joint, let us say the moment is MB. Okay, so can I write MB equals to MBA plus MBC? Okay, so this equation we call it as joint equilibrium condition. Okay, so from this joint equilibrium condition, we can find out the MBA value. Okay, so we will write that one. So from the joint equilibrium condition, from the joint equilibrium condition, we have MB equals to MBA plus MBC. MBA plus MBC. So this implies this will be 0. This implies MBA plus 16.37 equals to 0. This implies MBA equals to minus 16.37 kilonewton meter. Okay, the moment at here we have found out. Now in this one, here again I told, so the MBA moment, here it is the same, so it will be opposite, minus 16.37. This one came as 16, we have minus 16.37, so it is 16.37 and this direction is correct. Okay, now we need to find out how much is MAB. Okay, so if I will take the moment at this point, if I take the moment across the point A as 0, then I can find out MAB. Okay, so if I take moment at A equals to 0, the summation of moment at A equals to 0, this implies, can I write 80 into 2? See this diagram, 80 into 2 minus 16.37, again minus RBA into 4. This is minus sign here only, plus MAB equals to 0. This implies I can write MAB equals to minus 135.69 kilonewton meter. Okay, so if it is minus 135.69 means this direction in which I have assumed, this is wrong. Okay, so this will be, instead of clockwise, it will be anti-clockwise. Okay, this is again 135.69. Okay, so we have found out all the moments. Sorry, we have found out all the moments, all the reactions, and now what I will do, I will plot the diagram for the shear force, and it is I am leaving this other part, that is the bending moment, that is to be done by you. Okay, so let us draw that one once again. Here after that, there is no overhang kind of thing. This is A, this is B, this is C. Here we have, this is 40 kilonewton. Here we have 80 kilonewton. And let us say this is Q, this is P. This distance is 2 meters. This is again 2 meters. This one is again 2 meters. And this is 2 meters. Okay, so if we plot the shear force, in order to plot the shear force, we need to draw okay. So the first one is, here it is 78.015. This it will go straight, then it will come down. So this is 1.985. Okay, and again it will go up till 15.908, and then it will again come down and it will remain constant. This is 24.093. So this one is the area of the shear force, and this is your shear force diagram. Okay, so this is positive, this is negative, this is again positive, this is negative. Okay, so the shear force part, whichever is left, this is to be, this we have to do. Okay, so now some 7 minutes is there, so please respond to your roll calls. I am stopping the recording here, and those who are taking down, they can take